Hi, I'm Joel and welcome to your Tutor Online video lessons. Today I'm going to explain to you divisibility rules. Those are little tricks and rules you can learn in order to figure out if a big number is divisible by one of these small numbers here. I'm going to cover rules for 2 through 10. Once you know a divisibility rule, you'll be able to look at the number, be able to figure out if, let's say 2, 3, 4, 5, 6, 7, 8, 9, or 10 will go into that number evenly without any remainders. Alright, let's start with the rules. For whatever rule I'm working on will be in this top left corner here, so if you need to skip around the video to find the number you're curious about, that should be able to help you there. First, a number is divisible by 2, meaning it will go into that number without any remainder if the number is even. To tell if a number is even, we're just going to look at the last digit, and if it's 0, 2, 4, 6, 8, then the whole number is even, and it means 2 will go into that number. So 146, that last digit is 6, it makes it even, so 2 will go into 146. Over here is an example, 2,377. Only look at the last digit. The last digit is 7, which is odd. That makes the entire number odd, and 2 will not go into 2,377. Okay, the rule for 3 is we're going to add all of the digits up, and if the sum is divisible by 3, then the big number is also divisible by 3. Here's an example, 13,452. I'm going to add all of the digits, so what that means is 1 plus 3 plus 4 plus 5 plus 2 is equal to 1 plus 3 is 4, 4 plus 4 is 8, 8 and 5 is 13, and 2 more is 15. 3 does go into 15, so 3 will also go into this big number. Also, this rule is great if you're working with really big numbers, because you can keep on going until you get a small enough number that you just know the answer to automatically. So if we didn't know that 15 was divisible by 3, I bet you did know that, but just pretend like you didn't. 1 plus 5 is equal to 6. 3 definitely goes into 6, and that's just another clue to let you know the big number is also divisible by 3. Okay, to figure out if the big number is divisible by 4, all we need to do is look at these last 2 digits. We can ignore all the rest of the number. 24, we just ask, will 4 go into those last 2 digits, 24? Well, yes. 4 goes into 24 6 times, so 4 will go into this whole big number because 4 goes into the last 2 digits. The reason this rule works is because 4 goes into 100 evenly, and so it gets to, every time it gets to 100, you know it's just going to reset itself. So the rule for 4 is if the last 2 digits are divisible by 4, then the whole entire number is divisible by 4. Okay, the rule for 5 is very easy. Again, this is going to be one where we just look at one of the last digits. The very last digit, if it's 0 or 5, then the whole number is also divisible by 5. 7,123,265, last digit is 5, so the whole number is divisible by 5. Okay, the rule for 6. If the rule for 2 and the rule for 3 both work, then the whole number is also divisible by 6. The rule for 2 was the last digit is 0, 2, 4, 6, or 8. In other words, it's even. That works for 2. Check. But then we also have to check for the rule for 3, which, remember, we add up all the digits. 4 plus 4 is 8, plus 7 is 15, plus 1 is 16, plus 8 is 24. 3 does go into 24, so 2 works, 3 works, that means 6 will also work. 44,718 is divisible by 6. Okay, the rule for 7 is the most tricky one, but here it goes. You're going to look at that last digit, and we're going to double it. 6 doubled is 12. You're going to take that doubled last digit and subtract it from the rest of the numbers. 47 minus 12 is 35. And then ask the question, does 7 go into that result? 7 go into 35? Yes. And just like our rule for 3s, you can repeat this same process for as long as you need to until you get a small enough number that you know 7 will go into it. So again, double that last digit, subtract it from all the rest, and the result there, if 7 goes into the result, that's a yes to the big number. 476 is divisible by 7. Okay, unfortunately the rule for 8 is not super easy. We only get to look at the last 3 digits. So in this example, 3,376, go ahead and look at these last 3 digits, 376, and it's not immediately obvious that 8 does go into 376. But if you are stuck without a calculator, this will save you a little bit of mental math or long division work to test just these last 3 digits instead of a big old long number. 8 does go into 3,376 because it does go into 376. Although on the other hand, sometimes it's really easy just to take a quick glance at those last 3 digits, especially if you have a 0 in there and know that, well, 8 goes into 16, so since it's my last 3 digits and it works, it goes into that whole big number too, 2016. The rule for 9 is just like the rule for 3, except instead of asking if the sum is divisible by 3, we're going to look and see if it's divisible by 9. So here we go, we're going to add up each digit. 2 plus 3 plus 8 plus 7 plus 7. 2 plus 3 is 5. 5 and 8 are 13. 13 and 7 is 20. 20 and 7 is 27. And I know that 9 does go into 7, and it works. Same thing here, you can repeat that process for as much as you would like until it's obvious to you. 2 plus 7 is 9, just as one more clue to let you know it works. And we get to finish with one last easy rule, the rule for 10. All we're going to do is look at the very last digit in a number. We can ignore all the rest of the numbers in the whole thing. Just look at that last one. If it ends in a 0, then it's divisible by 10. So let's see what we have here. 100,000, million, billion. 4,765,000,000. 21,370 ends with a 0, so it is divisible by 10. Alright, well now you know your divisibility rules. You might need to review the lesson a couple times before it sinks in. I hope that will help you save some time next time you have to simplify fractions, or maybe for factoring, instead of just randomly punching in numbers to the calculator. Follow the rules. My name is Joel. I am your tutor online, and I wish you happy studying until next time. Be sure to leave any comments or questions you have in the comments below, and I will answer them as best as I can. Thanks.